Mark Maxwell took out a simple interest loan at 13% interest for 12 months. His previous balance is $2,681.04. What's the final payment if the loan is paid off with the next payment? Okay, so this is a really practical question. Let's say you're paying off a loan and you've saved up a bit of money and you want to know, would it be worth my money, would it be worth my time to pay off my loan early? Would I make a significant savings? Let's find out. So, whatever this final payment is going to be, our final payment is going to include interest that has accrued since our previous balance. So whatever balance I owed as of my last statement, my previous balance, I have to pay that, and whatever interest accrued on top of that previous balance. Now remember, my goal here is to solve for the final payment. So let's find out what this final payment is going to be. Okay, so we know that our final payment is comprised of our interest and our previous balance. Let's talk more about interest. They tell us it is simple interest, so we know we're going to pull out our I equals P for principal, R for rate, and T for time. Do we have enough information to plug in everything for interest? Let's see here. Well, we know the balance is $2,681.04. So that's our principal. Now you're probably used to thinking of principal as the original amount that we take out a loan for. However, principal in this case, or in many cases, can also just apply to whatever we owe right now. So right now, he owes $2,681.04. That's our principal. That's the most relevant figure to use. What's our rate? Well, it's at 13% interest. So we convert to a decimal and we write 0.13. For time, let's see. The interest, let's see, the loan was taken out for 12 months and he's making monthly payments. He's making monthly payments. They don't say that explicitly, but it's implied. So if he's making monthly payments, then our time is 1/12. Now the temptation is to write 12/12. We know that time must be in years. The temptation is to write 12/12 because you see that the loan is for 12 months. However, we want to know this figure is not based on how long the loan is, but how often the interest is calculated, which is every 1/12 of a year. So now we simplify and we find that our interest is equal to $29.04. Now please double check this on your calculator, make sure that you come up with the same number. If you're coming up with different numbers, you may have some settings wrong on your calculator that are going to make you wrong when you do other workbook problems. So now we're going to take this $29.04, plug it into interest here. We already know our previous balance is $2,681.04. Notice here also that previous balance and principal were the same figure. So it's possible for a number to have more than one term name associated with it. All right, so we're going to add our previous balance to our interest, which gives us a final payment of $2,710.08. So pretty straightforward here. The biggest step is realizing that our final payment would have to include not only the previous balance, but any interest accrued since that balance last month. Okay, let's do another example here. So in our last problem, we calculated a final payment. And this is the part with this example where we'll talk about how much money you save by making that final payment early. So we have Chloe who paid for a vacation. We're told what the cost of the vacation was, the rate, how long she's paying, the amount of her monthly payments. And we're told that after 5 payments, the balance due was $1,786.20. So if Chloe pays off the loan with the 6th payment, how much will she save? So our target here is to figure out her total savings. So let's talk about that. Well, interest saved would be based off of finding the difference between whatever she was supposed to pay back, right? So her total payback. And by total payback, I mean what she would have paid had she stuck to the plan and made all 12 monthly payments of $263.75. So we compare that by subtraction. We compare that to what she did pay, which is she made 5 payments. So the sum of all the payments she made, and then whatever her final payment was. So she made these monthly payments, and then she made a lump sum payment at the end. So this total in green here is what she did pay. So we're going to take what she would have paid compared to what she did pay, and that's going to tell us the total amount of interest that she saved. Now, to be able to get to this, we need to know what her final payment was, just like in the last problem. Okay, so let's start there. We don't have to start there, but I think it's a good place to get going on this one. So what is her final payment going to be? Well, just like before, the final payment is going to be comprised of 2 things. It's going to be the previous balance, and then we'll add in whatever interest has accrued on that balance since the last time interest was calculated. So interest, again, this is going to be simple interest. We'll still use our I equals P times R times T. Let's see if we can fill in what we know. So our principal is going to be based on whatever our previous balance is. So our principal, what she currently owes, the balance due, is $1,786.20. $1,786.20. So again, noticing that this number is going to serve as both principal and as previous balance. We're going to multiply that by our rate, which is 10%, and we write as a decimal 0.10. Our time. Remember, don't ask yourself how long is the payment. Ask yourself how often interest is calculated for this payment plan. She's making monthly payments, which means interest is calculated every month. So we multiply by 1/12. Again, every 1/12 of a year, interest is calculated. Our unit has to be in years here. So we take $1,786.20, we multiply it by 0.10, and we multiply by 1/12. And we get interest is equal to $14.89. So that's what we plug in for interest here. We also know that our previous balance is $1,786.20. We add that to our interest, $14.89. And we get that her final payment was equal to $1,801.085. Notice that I'm not rounding off this 5. Okay, so let's just take a look at what we've done so far. We know that whatever interest she saved is going to be based off taking the difference of what she would have paid versus what she did pay. Part of what she did pay includes her final payment, and I just chose to tackle that first. Her final payment is based off whatever she previously owed and any interest it's accrued. To find that interest, we did our simple interest formula, remembering that time is based on how often interest accrues on the loan, which is once a month. Once we found interest, we plugged in interest in previous balance to find a final payment of $1,801.085. So now that we have the final payment, we're ready to move forward and start plugging in to this interest saved formula. So let's do that. So our interest saved is going to be equal to our total payback. So what would our total payback have been? What was she supposed to pay? Well, she was supposed to make installment loans for 12 months. So she was supposed to make 12 payments of $263.75. Her monthly payments are $263.75. So had she followed the terms of the loan, she would have made 12 payments of $263.75. So again, that's what she would have paid. We're comparing that to what she did pay. So first, that includes the sum of the payments. So the sum of the monthly payments she was making. So how many did she make? She made 5 payments. So she made 5 payments of that monthly rate, $263.75. But she also made that final payment of $1,801.085. So now we have our entire formula set up. It's just a matter of executing it. So you can plug this into a calculator the way I have it. You would have to include these brackets the way I've done, maybe even including parentheses here. So I encourage you to practice that, because if you don't use parentheses correctly, brackets correctly, if you don't do your order of operations correctly, although your work is correct on paper, your calculator entry could be wrong and you might get the answer wrong. So it's usually a safer step to do some of the work in shorter pieces. So for example, you might start by taking 12 times $263.75, which is $3,165. Then you might combine the right-hand side, first multiplying 5 by $263.75, and then adding that figure to $1,801.085. And that would give us $3,019.835. Then you would subtract these two figures, and your final answer would be $45.17. So the total interest saved was $45.17. Now this is where common sense and reason comes into this, because we have to ask ourselves, was it worth it for her to put up a bunch of money to save $45.17? So think about making that major payment. Would it be worth it to you to be able to make those smaller payments month to month, honor the loan, and spend an extra $45.17, or is it worth it to you to save the interest? Personally, I would have probably just paid off the loan in the 12 months, but $45.17 maybe was worth the savings to Chloe. So again, interest saved was based on comparing what she would have paid to what she did pay, breaking those down into parts and coming back together, carefully combining some of our operations in the end here to make sure we don't make simple calculator mistakes.